Good morning, everyone, or afternoon, depending on the time zone. My name is Mark Hughes, and I'm here with Royal Circuit Solutions, a premier PCB fabrication facility in California that's been in business for well over 15 years, creating the fastest PCB turns in the printed circuit board industry. Today, we're going to talk about design tips and cost-saving tricks with Elijah and Riki Gracia, two of Royal's best brothers. I tell you, I've met quite a few brothers. There's actually quite a few families working at Royal. These guys are absolutely my favorite brother pair. With that, as we go through this, you're going to have the opportunity to ask questions and ask them at any time. If I can fit it in and I'm paying attention to the Q&A box, I'll be happy to answer the question right then and there. Or if the question doesn't necessarily fit or I miss it, we'll pick them up at the end of the webinar. Well, with that, you've already met me, so let's meet the two guys that are really going to make this happen, Elijah and Riki Gracia. Elijah is one of our CAD/CAM engineers at Royal's North facility in Hollister, California. Elijah's been with us for about 6 years doing various jobs, and right now he's one of our premier engineers. He's the guy that makes the boards happen. Elijah, would you like to introduce yourself?
Yeah, hey everybody, my name is Elijah Gracia, and I've been working here at the engineering team at Royal Circuits North for the last 6 years. And hopefully I can add a little bit of value to your PCB knowledge today.
I'm sure you can, Elijah. Although looking at our attendee list here, and I don't want to intimidate you, but one of my personal heroes is watching today.
Uh-oh.
So yeah, I know. I mean, I expect some good questions out of that particular gentleman. And if he's really treating us the way that I think he might, we won't be able to answer him. I'm kidding. We will. We'll be great. Also, we've got Riki. Yeah, no pressure. He's a great guy and very, very kind, very magnanimous. I don't want to call him out by name, but this gentleman might remember at Altium Live that I met. I spoke for a few minutes with him and his wife in the hallway on the first floor right before the Altium conference room. Okay, moving on to Riki. Riki is a ton of energy. Riki works in our sales office at Royal South facility in Santa Fe Springs, California. Riki's been running sales down there for the last year, and before that was at the Royal North facility for an additional 3 or 4. So his job every day is to make sure that customers are getting what they ask for when they ask for it. Riki, would you like to introduce yourself?
Yeah. Hey guys, thank you for joining us. As Mark said, my name is Riki. I'm a sales manager down here at Royal South and Royal Flex. I've been with the company for about 5 years, and I'm just here to help bring some insight on how you can get the most out of your design while still saving on cost.
All right, thanks, Riki. Can't wait to hear about it. Our webinar today is broken into, well, our webinar isn't advancing. And now it's advancing too fast. Give me a second. Our webinar is broken into 4 parts. We're going to go over a little brief background, then talk about vias, stackups, and surface finishes, followed by a Q&A. With that, I'm going to get out of the way and let Elijah and Riki run away with it. Have a good time, guys.
Awesome. Thanks, Mark. All right, everybody. Glad you all can make it out here. Let's get right into it and take a look at our traveler. And to start, we're going to have an example of what one of our travelers might look like. And we just want to take a quick look to help understand some of the cost-saving tips that we're going to be going over today. And so a traveler is basically the instruction manual that we create for every order that comes into our shop. And once we figure out the exact approach to take to your build, we print these out and give them to the production floor. And each traveler kind of has its own custom instructions based on your design. And these travelers go from anywhere from 2 pages to 20 pages long, and depending on the technology you got going on. So if you're looking to reduce the cost of your board, we want to prevent as many unnecessary steps as we can. And if you look on the right side, we have an image of an array, and this array has 64 individual boards on it. And the reason we want to take a look at this is kind of to explain yields, or the overall number of usable boards and the level of risk that we take when we're building your design. And as you can see, 6 boards have been crossed out. These boards might have failed due to overplating or misregistration. Whatever the case is, we're able to yield 58 good boards on this. And so today we're going to be touching on some of the tips and how we can improve your yields. This might not be something that you've considered when you're ordering PCBs. You know, you might have ordered 20 boards, but we definitely have to be making extra to make up for some of the issues that we might be running into. Riki, do you have anything to add to that?
Yeah, that's right. So just like Elijah said, there's many different variables that go into manufacturing a quality circuit board that often are either just not considered or just might be overlooked, especially working with prototypes and up and coming technology. So working closely with both our internal engineers as well as our customers and designers, I've come across some instances where a small change at the recommendation of our team has not only saved money, but in my opinion, more importantly, time. Time is money, right? So the more steps or manual processes we need to take while manufacturing your design, the higher your cost. So to combat that, Royal offers you several different tools and services, which we'll get into here in this webinar and discuss a little bit about. So what I recommend to all of our customers right from the beginning when we bring somebody new on board is taking full advantage of these services. Not many companies offer them. It's something that Royal loves to give to their customers because the easier it is for us to manufacture, we're able to transfer those savings over to you. And also addressing any concerns at the time of quote. So at quote stage, just get it done early so this traveler stays thin. And it'll also maximize the exposure our engineering team has to your design. So once we start tooling and getting that process going, we've already spoken to you. We know what's going on with your boards, with your design, and what you're trying to achieve. So that minimizes any holds, any delays, which is also, again, priceless. You get boards on time, and we get you a great deal because it's easier for us to manufacture. We know what you want. We don't have to sit and go back and forth with you. It's just some great tools to get into.
Awesome. Thanks, Riki. And let's move on over to vias. Talk about that really quick just to help understand everything that we're going to be going over. And just a quick overview, a via is a plated hole that's used to make connections through different layers, right? And so on this slide, we can see a few different types of vias that we're going to be covering just a bit. But first, let's explain how a via is actually formed, right? Just again, so you can better understand what we'll be talking about. And so really quick, if we look on the very first image on the left, once all of the layers of your board are ready, that's the first image. This is the final sandwich laminated, good to go. Next step is we're going to drill that hole all the way through the board. And that's what you're seeing in the second image. Next to that, we're going to cover the rest of the board in a film to protect it. And now we're going to plate additional copper. And this step adds copper to the surface and also forms the barrel walls of that hole. And then the last step, we're going to be etching off the copper to create the via that you designed. And so that's just the basics of what it takes to make one via. And this is just a standard via, but once we start using blind or buried, now we have to start building your board in multiple stages. And here's where we start to increase yield risk, turn time, and cost starts going up. Do you want to add anything to that, Riki?
Yeah, just like Elijah said, the more lamination cycles, the more steps it takes. And again, one of the biggest cost factors is risk. We want to make sure we get the maximum amount of yield as possible. So one joke I always have for my customers when they're used to quoting our standard boards and then they introduce some technology into their designs, they want to know, well, why is it so expensive? Why is my cost so much higher? Well, the joke I give back to them is, well, do you really need the blind and buried vias? Well, obviously for functionality reasons, they need to be there, right? So what I've found is that's not always the case. Just to give a quick example, most recently, I had a customer who had a sequence of blind and buried vias that he needed to achieve a particular connection without shorting out one of the adjacent layers. This customer worked with our engineering team. He gave us a call. He utilized our resources. And in looking over his data, we were able to recommend an alternate method using the controlled depth drill. Okay, that not only saved on costs, but it shaved about 4 to 5 days off of his time, which is, again, priceless, just as good as money, right? When we can get boards on time and to our customers with the same type of technology. And that's something that Royal loves to excel in. So this isn't saying it's possible with every design, but it's an example of how options can be overlooked, whether it's just not knowing what options are available to you, but it can make a board very expensive, especially once you start getting into multiple lamp cycles and so on and so forth. So again, I can't preach it enough. Talk to our team. Let us tell you or give you an idea of what options we have to provide to you. And that's always going to help you save time and money.
Awesome. Thank you. And so,
Elijah,
yeah, go for it.
I was going to say, before we go on, could we talk briefly about how blind and buried vias are fabricated?
Yeah, definitely. So if you take a look at this slide we got right here, we got a few different types of vias, and starting from the left, we have the buried via, or a plated hole that doesn't reach either side. And as the name kind of suggests, it's actually buried into the board. And then next to that, we have the blind via, which is a plated hole that starts on the top or bottom, but it doesn't reach the other side. And then the third image is a standard via that's just a plated hole. It goes all the way through. We just talked about it. And this is the simplest form of making connections throughout your layers. And next to that, we see the stacked via. It gets a little more complicated, as you can see. These are actually made by drilling and plating the very center layers of your board. And then we add the next set of layers after that, drill and plate again. And this happens over and over. And depending on how many layers you have, you can see those vias keep stacking on top of each other. And last, we have an example of the staggered via. This is made the same way as a stacked via. The only difference is the design has the vias staggered or offset. As you can see, the vias aren't directly on top of each other. And it's really only used when you don't have a lot of room to work with in your design. And any questions before we move on to that?
Well, I do have a question for Riki. We were talking a moment ago about using some back drilled vias versus some blind vias for controlled depth. As a designer, the reason that I might choose to use one of those, if I'm using a high-speed serial link, for example, whenever I reach, I have to transition layers, it creates a stub, and that can cause a point of reflection. So the real question that I have with all of that is, sometimes I have to change layers. It's just going to happen. How can I save money? How much does the back drilling cost? What's the cost increase, percentage-wise anyway, for a stacked versus a staggered micro via? I know what I have to do as a designer, but I don't know how that affects my cost structure. So maybe you could help us out with that, Riki.
Yeah, so each pricing is going to be per design. So it's what other technology is involved with your board that we need to take into consideration. But as far as going from something like a back drill to a blind via, it's usually around 25 to 30% in cost savings. It's all going to depend on whether your design allows for it. Like I said, in the instance that I provided, the customer was able to adjust their design to where we can make it possible. My best recommendation is to get with our engineers and let them know, hey, this is what I'm trying to achieve. What are my options? And these guys work daily, day in and day out with different types of designs, and they're able to say, hey, I've seen this in another design, and this is how we can save you money. This is a simpler process. We may be able to use this with mechanical drill rather than laser drill. If you can increase your via size, so on and so forth. There's so many different variables. It's really hard to get into exact pricing, but speaking to our team, speaking to your rep, we can usually save around 25 to 30% going from a back drill to a blind or a buried via.
Do you think, Riki or Elijah, that you could maybe order these for us, least to most expensive?
Yeah, so obviously a through hole is going to be your least expensive. It's the most common. The blind via would be next, dependent on what layer it's going to, the dielectrics and all that good stuff. But generally speaking, it's probably your most economical. We would go from there to a buried via. Again, depending on your design, how many lamp cycles and so on and so forth. That's usually the next in line. And then stacked vias, and then staggered vias. Staggered vias is going to be a little more difficult for us to achieve, but definitely manufacturable. It takes a lot more processing. a lot more engineering, a lot more tooling, may hit, the drill machine or laser machine a few more times than normal to make sure we get it right. All the registration has to be there. So just with these examples here, that's probably going to be your most expensive selection.
All right. This stuff has been great, but I have two more questions for you. What about hole size versus cost? Well, so let's say I need a through hole just to make things easy. Does a 20 mil via cost more than a 10 mil via?
No. The only time you're going to incur a higher cost is when it goes from a mechanical drill to a laser drill. So anything below 6 mils usually is going to require a laser drill or custom bit, so on and so forth. So as long as you stay within industry standards or specs, you're usually there's usually no cost adder for that.
What about from a plating reliability standpoint, Elijah?
As far as the hole
The
size?
10 versus the 20 mil, yeah.
Oh yeah. Well, we have these new pulse plating tanks actually that are able to really do a great job on these smaller holes now, and that's one of our key things we've been pushing. But as far as cost, it's not going to affect anything.
Okay. And then one last question for you before we move on. The other questions that I have coming in are going to have to wait till the end. But are more holes more expensive than fewer holes? If I order a board that needs 200 drills versus 500, will there be a significant price difference?
So it's going to depend on how many holes we're going to need to drill per panel. So we like to stay around 25,000 holes per production panel. Once we start eating up drill time, let's say you have 10,000 holes per board and we got 10 boards on a panel, then, that panel is going to be sitting on a drill machine for a while, taking up time. So once you start getting into the big numbers, anything, like I said, above 25,000 per production panel, that will add to costs. But again, speaking to your rep, talking to our engineers, we can help alleviate some of that, or, find out alternate methods for you. But unless we're getting into some big numbers, then we're usually okay. Okay.
Stephen, since your question is a signal integrity one, I'm going to hold that off towards the end. And Jeffrey just added one last one, and this will be the last. Keep asking questions, guys, but this will be the very last one we do before we move on. But the question is, what's the delta between specified hole and drill size? I believe that to mean, Elijah,
Yeah.
if I call out a 5.9 mil drill, am I getting a 5.9 mil drill, or am I getting something a little different? Oh, you know what it might be too? What happens to the hole after the plating? I'm not really sure which way he's going with that.
Okay, well, either way, what you're requesting is exactly what we're going to give you, as long as your annular ring and your space can adjust to that. If not, we will contact you and let you know, like, hey, you don't have enough space to be doing this drill. We're going to change the size. And as far as what you're asking for versus what we're actually drilling at, we always compensate. If you're asking for a 5.9 drill, not to go into too much detail, but depending on which finish you're using, whether it's ENIG or Hassel finish, we have compensation calculators that automatically change the drill size so that it knows it's going to drill one size and compensate for the plating we're going to add so that we can finish as close to your hole as we can.
All right, thanks guys. That was a lot of great questions from our audience too. So thank you so very much. And yeah, I've got a significant lag since I'm running this from a hotel room, but I'm trying to get our next slide up for you, Elijah. There we go.
Awesome, cool. Let's jump right into via filling. Now that we've talked about the different types of holes, how can we fill those holes now? And there's a few different ways to do this at different price points. Let's start with the open via. This is just standard via, what we've been talking about. There's no fill, no outside coverage. Everything's exposed, right? This is just standard. And the first level of protecting these holes is going to be to tent them. That's the tented via image you see right there. And here we're just covering them with solder mask, kind of creating a blanket over the surface of the hole. And this is done at the same time we're already applying the solder mask to your board. So it's not too much of a price adder. We're just making sure that that tent stays solid. And the second level is going to be that LPI filled via that you're seeing. And here's where the hole is completely filled with solder mask to give an additional level of protection from moisture and corrosion. And it's going to be your middle option. And it's still less expensive and cheaper than our last type right here, which is going to be that capped via, or also known as epoxy filled vias. And here we're going to be filling the hole with an epoxy based liquid. Then it gets baked and cured, and we're going to plate that hole shut on both surfaces. As you can see, that top layer of copper right there gets it nice and capped. And this is something that it's really only necessary in like your BGA designs to help improve your solder connection. And so as a recap, each via kind of has its own purpose. They might not always be necessary, but when you send your design, we want to be able to help you decide if any of these might help improve your overall yield or the functionality of your board, or maybe let you know that what you got going on isn't exactly necessary for your order. Anything to add to that, Riki?
Right. Right. Yeah. So just like Elijah said, epoxy refill is going to be your main cost adder when it comes to via filling. It's going to increase your cost and it's going to increase your lead time, right? So sometimes there's no way around it. You need what you need, just like Elijah said with BGAs, stuff like that. It's required via Impedance and so on and so forth. But one thing to keep in mind is if it's a prototype design, a design you know you'll be up revving soon, something that doesn't need to stand the test of time, the LPI fill or via tenting are great options to achieve similar functionality. Not only are they less expensive, but they don't add to the lead time in most cases. So if you're not sure, like Elijah said, get with your engineers and we'll let you know what options there are. Just, taking a quick look at the image here, the open via all the way to LPI filled via, from a pricing standpoint, it's all going to be around the same price. So I would recommend talking to our team and just seeing what options you have available, and we can work with you. That's not a problem at all.
Awesome, thanks.
All right, we've got two questions that have come in. First one from Jim. What is the largest via diameter that can be completely tinted with standard solder mask? And I'm going to amend his question slightly to say, what's the largest via diameter that can be completely tinted reliably with standard solder mask so that it's not going to collapse on you?
Right. We try to stay, I think the biggest we can do is about 50 comfortably, where we can guarantee that structure is going to stay sound.
All right. And sorry, I'm still fighting the lag here. We've got some questions. If you need some vias filled and capped, is it more expensive to do them all filled and capped or just the ones that are required to be filled and capped, like the vias and caps?
So we call that either selective via fill or global via fill. It depends, honestly, on what type of fill you want. So we have a non-conductive epoxy via fill and a conductive via fill. For the conductive via fill, yes, the amount of surface that we need to fill is going to increase the cost. For non-conductive via fill, it's usually a general standard cost for material and process time. So it all depends on your design, but for the most part, generally speaking, it's a standard cost throughout, unless you're going to go into conductive via fill.
And just to follow up on that, and I don't want to get the names right, but I want to say Dr. Douglas Brooks and something Adams recently wrote a book where they looked at the results of IPC standard 2152, and they found that the via temperatures don't vary significantly from the trace temperatures above and below them. So unless you're really dealing with a ton of current, you might not necessarily need the conductive via fill that you think you do. And I can't remember the name of the book right now. It's only been out a few years, but look for Doctors Adams and Brooks, B-R-O-K-E-S, and you might be able to find that or follow up with us after, and I'll definitely get you the ISBN and all that. Should a via be tinted on both sides or just one?
That just depends on your design. If you only have components going on one side, usually customers will only tint one side. But if there are vias that aren't going to be used or they're away from components, then hey, plug them both sides. It doesn't hurt.
Yeah. To answer your question too, Jeffrey, it really comes down to two things that I can think of. One is reliability. Are we going to get acids and whatnot to enter the via cavity and cause degradation, or moisture that enters and gets into the substrate over time. But the other reason that you use that is to prevent something called solder thieving, which we've got a webinar on, one just dedicated to avoiding things like that, designing for manufacturability, designing for assembly. The issue is that solder, we put it on the board in a paste, and if there's a hole in the board and we start, heating this board up in a reflow oven, the solder and the paste just fall right down into the hole, and you're left with insufficient amounts of solder on your pad. It's really bad. So there's a lot of variability to it. Via tinting isn't as reliable as via filling. It's just an affordable option. So if we're going to be tinting, tint, baby, tint. All right. Let's see what else we can do before we have to move on. The question is from Vamsi Tala, and I think we covered this. Is epoxy conductive or non-conductive in the epoxy-filled and capped vias? We can do both. Oftentimes, customers will ask for the conductive fill where they don't necessarily need it, and that increases the cost of the board unnecessarily. I'm sure there's some people that are, we do have some customers that are really on the bleeding edge of technology that, they need it, we give it to them. What about filling the open via with solder during reflow? No, that is okay. So, Vadim, there's two types of soldering that we use in the assembly process. One is reflow, where we basically put a paste on the board and we put it in an oven. Oven heats up. The solder flux melts first, and then the solder metals melt, and it would be really difficult to put enough solder on to fill up a hole reliably. It would suck from all over the area. There's another kind of soldering that we do called wave reflow, where basically you take molten metal and you have this little jet nozzle that comes from underneath, and it sprays the bottom of the board and it fills the hole. If you did that wholesale over a board, I can only imagine that it would warp a ridiculous amount. Your board would be a bowl rather than a flat surface anymore. It wouldn't necessarily be a good idea from an assembly standpoint to do either one of those options. If you're going to fill it with LPI or the epoxy. Other than that, tint it. Other than that, I would say probably you're best leaving it open. So I hope that answers your question. Question is wave soldering still common today? It happens. I mean, there's still through-hole components out there. All right, with that, there are some open questions I will try to pick up if we have time at the end. If not, we will have to follow up with you one-on-one. All right, Elijah.
Awesome. So let's move on to talking about impedances. And impedance is the combination of resistance, inductance, and capacitance. And to simplify that, here we're just trying to control a specific circuit to flow at a specific current of electricity. And this is controlled by the trace width or the space width if you're talking about differential pairs like that second image, and the dielectric spacing between the layers. And this process can be very time consuming for both you and the board shop. So hopefully you're taking advantage of one of the many impedance calculators that are out there, like the one on our website. And as an added bonus on our side, we also have STACKUP specialists. Teresa and Omar are two engineers that we have dedicated just to engineering STACKUPs, and that includes impedance modeling. And this is a huge tool that can really help you a lot. And so after looking at your design and your impedance requirements, we're able to create the STACKUP shown right here on the slide. And on the bottom, it's going to show you that the impedance structures you're requiring. It's going to show you if we are suggesting any changes in that based on our calculator. And on the far right of that bottom picture, it's going to tell you the predicted current that we're hopefully going to be able to get. So not only are we giving you the right trace and space size when you're asking for our help on this, but on the top right there, we're also giving you the exact STACKUP that we're going to be using to build your board. And from the engineering view, I love when data packages come with something like this. They've already done the homework. They took advantage of our resources, and this is going to be a smooth job with little to no problems because the hard work's already been done. And so this is just a huge tool that you guys should really be taking advantage of. Talk to your fabricators and see if they offer something like this. Anything to add, Riki?
Yeah. Also, this is, another key point or a crucial area where it can definitely help save you money by using, like Elijah said, the tools offered to you, including our online impedance calculator, our STACKUP and impedance engineers, Teresa and Omar. This is where you can get the most bang for your buck, guys. So we pay the engineering time. That's unheard of in the industry, right? So this resource is done free of charge. Teresa and Omar, they do an amazing work with making sure your copper weights, your trace and space width, your impedance models, they all marry together. And like Elijah said, it's all put together in a clean data set that makes for a quick and easy tooling. It ensures the build hits the floor in a timely manner, and it minimizes the engineering questions, the holds, kind of like we covered earlier. So, take advantage before we realize what we're doing here. It's definitely a key tool.
Awesome.
All right. Thanks, guys. Do you have time for a quick question?
Of course.
Sure. Elijah? Oh, you should have said no. Should have said no, buddy.
I don't.
All right. Okay, so we've got two, and Rico is surely making the most of this free webinar. When you specify impedance, should you specify the target impedance or the target impedance at the desired operating frequency?
You're going to give us the desired impedance that you want.
Okay, but I mean, let's say I'm doing something crazy, like I'm engineering a 12 gigabit per second link. How do I relate? How do I let you guys know that? How do I make sure my board's going to work?
In most cases, people are just giving us just what they want to reach, but we do have instances where the customer is saying, here's exactly what I'm doing, and we're going to take that into consideration. Teresa and Omar are going to take a look at that and try to figure out how we can best meet that impedance at whatever it is you're trying to run it at.
So you guys mean you'll help me figure out the dielectric that I need to use as well?
Absolutely. That's all part of creating the STACKUP that we give back to you.
Okay. Hopefully that answers Enrico. If not, please ask again with a little more specificity, and I'll hit them again. Next two questions we've got: do you verify the STACKUP that's provided by your customer, or do you just accept it as is?
We always verify. If you're asking for impedance, we're going to check it, double check it, even have another engineer check it, just because we want to make sure we're giving you what you want. And it's not uncommon at all that we find mistakes in customer STACKUPs.
All right, and that'll result in engineering hold, correct?
Yes. So we're going to stop it, let you know the changes that we would suggest, and go from there.
Okay, we've got quite a few questions that I'm going to answer all at once. I'll read the questions and then I'll give you the answer. Do you support coplanar waveguide calculators on the website? Do you support calculators on your website? And then the question that I really want to answer is, are the calculators on the websites anywhere near as good as working with the engineer? Or should we use the calculators to ballpark trace widths during the design and then inspect some back and forth with your engineer on the STACKUP after they review the design? James, that's a great question. The calculators aren't great. The engineers, and I wouldn't say work with the engineer at the end of your design, I'd say work with the engineer at the very beginning. Because they're going to give you an order of magnitude greater reliability than anything that you're going to find online with a generic calculator. There's all sorts of thickness and width concerns that the calculators online just don't take into account. Are you using heavy copper? Well, if so, they're going to have to use they're going to have to use some pre-preg with more epoxy in it. It might be a little bit thicker. You might not have taken that into account. Did you take your copper thickness in? All of this, our engineers are all over. I mean, that's all they do all day, every day. So they're going to help prevent quite a few gotchas that the online calculators, and I've seen them and I've used them, and oftentimes they've bitten me in the butt. I wouldn't. Also, the online calculators seem to really fail when you start getting down below about 5 mil traces for whatever reasons. They just end up being horribly inaccurate. Anyhow, talk to the engineers. Even if it's not our engineer, although, I mean, talk to them. It's free. You can't be free. but talk to them at the beginning of your design. Once you realize that you need a high speed or an impedance controlled trace, you get on the phone, hop on an email. So I hope that answers everybody's questions at once. What's the tolerance for specified impedance, Elijah?
That's going to be 10%. So for a 50 ohm call out, it's going to be as high as 55, as low as 45, but always 10%.
Okay. This question, I'm going to try to go through these a little quicker. The decay is frequency dependent. So if we say 50 ohms, that could be at 2 megahertz or 60 gigahertz. How do you know? And Enrico, that's a question that you need to ask directly to our engineers. That's getting a little bit outside of the area of expertise of the engineers we have online right now. We can get it answered for you, but we need to answer it with the right guy. Does Royal outsource copper-filled vias?
No, we do that all in-house.
Okay. Vancy, I'm going to have to wait till you're towards the end if we have time. This is one last question, and then we're moving on. I'm going to leave some unanswered until the end. Can you go over the material usage you work with and what might be the tolerance of materials once they are used? So what all different materials do we work with, guys?
Man, we have this huge room right across the street full of material, and that's kind of an advantage that we have. We deal with a lot of FR4, Rogers material. There's so many to list.
Panasonic P95.
Yeah. We've really got a little bit of everything here in the shop, and we like to kind of have that edge on the PCB game.
Okay, and we can get anything we want as far as copper, right? Rolled annealed versus electroplated.
Yeah, exactly. One of our suppliers is no more than an hour away, so whether we have to go pick it up or they'll make a special delivery for us, we can get material pretty quick.
Okay, let's go ahead and move on to our next slide.
Awesome. So now that we've talked about vias and the controlled impedance, let's transition right into Stackups. And here's another example. If we go back to that last slide.
It's going to take a second. I already clicked on it, just waiting for it to come up.
No worries. So here's an example of a Stackup, or to put it in simple terms, here's the direction that we're going to follow when building the sandwich that makes up your board, right? So every design has its own Stackup rules based on the overall thickness that you want to achieve, the copper weight you're going to be using. And when you add things like blind and buried vias or controlled impedance, those rules start getting tighter and tighter. And obviously, the more layers you have, the higher price can be. But there's kind of a lot of hidden misconceptions in there. Ricky, do you want to touch on that really quick?
Yeah, so just like I said, so one of the most common misconceptions that I hear as a sales manager here is, hey, the thicker the board, the higher the cost, right? Well, again, that's not always the case. In fact, the thinner the board, it can actually become pretty expensive compared to like a rigid 250 mil thick board. So once we fall under a standard thickness, there's so many things that need to change, so many things that need to be done in order to accommodate those thinner type builds. So we have to change the machinery we use. Several of our automated processes now either have to be done manually or they just change altogether. So for instance, standard mechanical drill, once we fall under a certain thickness, standard mechanical drill bits aren't going to work. It's going to eat up your board, whether it's a flex or rigid flex, and it's not going to work. So we need to change that to a laser drill or a laser route, which will increase costs. Chemical cycle times, bake times, everything needs to be changed for the most part to accommodate the thinner material. So making sure we use the right Stackup is critical to cost savings. Again, working with our engineers, I know as far as the impedance goes, one of the questions was about material. So one of the things that our online calculators can't do is recommend equivalent material. Our engineers can say, hey, you might need, AP 9121, but if you use, material X, this is the equivalent. It's going to hold the same dielectric constant. It's going to give you the same reliability, whatever it is you need, and it's cheaper and it's more readily available. So again, using the tools, using the resources, I can't stress that enough. Talking to our engineers is going to be key.
Awesome.
All
Thank
right.
you.
Thanks, guys.
All right, so jumping over to the layers and lamination cycles on your STACKUPs. So let's say you have an 8-layer board with stacked vias on all the layers. This is going to require 3 to 4 lamination cycles. And the more lam cycles we're doing, that's when the price starts going up and increasing the amount of steps in the build. We're taking more risks on how many good boards we're going to get, and maybe your design doesn't even require stacked vias. So instead, you might be able to move around and work out some blind vias instead, which is only going to require 2 lam cycles. So that cuts it in half, and cheaper way of achieving the same function. And like Riki covered earlier, it's not always possible, but sometimes it is. And moving right into the next slide, continuing on to STACKUPs, we're going to talk about one of the main things you should be focusing if you're suggesting a STACKUP to us, and that's balanced STACKUP. That's when you're wanting a symmetrical design. And what I mean by that is if you were to cut that board in half down the center, you want the top side to mirror the bottom side exactly. So if you look on that left side, we're going to look at a balanced STACKUP. So there's 2 pieces of 106 prepreg between layer 1 and 2. That's those yellow bars you're seeing. So to balance that or mirror it, there should be 2 pieces of 106 between 7 and 8, which is your bottom layers. Oh, I'm sorry, we're dealing with a 6 layer here. So between 6 and 5. And so that's going to have your balanced STACKUP. Now we jump over to the right side. And if we start adding more prepreg to one of those, so as you can see on that bottom side, there's a lot more yellow bars. That's representing the prepreg we're using. Now that side is going to be a lot stronger when we laminate your material. So when it starts to bake, that bottom side's strong and the top side doesn't have as much prepreg, so it's going to give and it's going to want to conform to what the bottom side's telling it to do. And that's when you start to get warpage, or that's when your board starts looking like a potato chip, basically. And it can also cause delamination. That's where your layers are starting to separate from each other, and that's all bad. You don't want that. So balanced STACKUPs, people. That's what we really want to make sure we're getting.
All right, and I'm going to hold questions for time just for now, but we'll pick up whatever we can at the end. Elijah?
Awesome. So the next part of that STACKUP is choosing your copper thickness, and we're just going to touch on this really quick. The other part of the STACKUP that not a lot of people think about, and here's a quick chart to help you decide which copper weight is required for your design. Most designs are going to be okay with anything from 1/4 ounce to 1 ounce copper, no problem, no difference. But once you start having higher currents in your board, that's where you're going to want higher copper. And to ensure what copper weight your design might need, shoot us an email, give us a call, and we'll help you figure out what you want to need. But this chart's definitely helpful for helping you figure that out. And then
One thing I'd like to
go for it.
I was just going to say, one thing I'd like to jump in. A lot of the online calculators right now are based off ITC 2221, which is no longer being used. It's completely, or it's been found to be completely over conservative as far as copper trace width and thickness go. 2152 has superseded that standard, and that's what these equations are based on.
Awesome. Thank you,
That's
Mark.
all for me.
All right, so let's jump into the next slide, which is going to be another part of STACKUPs, and that's your trace and space minimums. So based on whatever copper weight you're using, we have different minimum trace and space sizes, right? So if you look on that bottom left, we're going to see the chart version, and this is something I use here at Royal. It's pinned to my cubicle. I use it every single day just to kind of remind myself and make sure I'm allowing the right things to go through the shop. So if you look at the very top line, that's going to be the 1/4 ounce copper, the 0.25. That smallest trace we can get is going to be 3 mils. And the smallest space we're going to be able to do is 3.5 on an outer layer or 3 mils on an inner layer. So on this chart, each copper weight kind of shows the minimum trace, the space you're allowed, to make sure we get a good yield rate and help keep costs down. But something that we get asked a lot is if we can break these tolerances, and the short answer would be yes, we can definitely achieve tighter limits than what's listed on the chart, but that also comes with higher risks and cost increases, because that's where our production managers start having to babysit the board and watch them through every process to make sure we can achieve what you're asking for.
Right. So actually, we'll go to the next one, and I'll kind of jump in here. So stiffeners, adhesive, thickness considerations. Your layer STACKUP isn't just copper and dielectric, right? So especially with flex and rigid flex, adhesives, stiffeners also come into play. And I know it sounds repetitive, but I can't express enough just how important taking advantage of the resources are. The recommendations, especially dealing with flex and rigid flex, there's so many different options, so many different variables to take into consideration. Way too many to go over in this webinar here, but with just one quick example, not too long ago, we had a customer who submitted a 3-layer rigid flex design. It was borderline unmanufacturable for us, just the way it was laid out. I know it seems something simple, but our engineering team was able to achieve the same desired result in that design by just creating a 2-layer flex and adding a stiffener, in critical areas. So again, just making that connection with Royal and making sure that you use those resources is definitely key. Just to briefly cover stiffeners, not a lot of people know what they're really used for. So a stiffener is generally used in specific locations in a flex build, and it's commonly placed underneath where a component will be placed. And all it does is it provides that rigidity while allowing the other portions of that flex cable or circuit to bend as needed. That just it helps keep the components from popping off during assembly or while the rest of the board's moving around. And then to kind of dabble in adhesives. Adhesives are not only used to fuse cover lay on a flex build, but it can also be used to adhere the stiffener to the flex PCB. So there's different methods, different ways of doing that. It's considered material, so it's going to add thickness. It's going to add some type of value to your board that needs to be taken into consideration during design. But all of it plays a part when thickness is a concern, just like I said. So at times options may be limited based on how the flex circuit itself needs to bend, whether it's a static bend or a dynamic. In this case, the thicker the board is, the more your bend radius is reduced, and vice versa. It's not to say we can do 90-degree bends on really thin boards. Everything is going to play a part. If you have gold, copper, that only has so much bend it can tolerate, without cracking. So there's, again, several different variables. Each design will be its own individual case, especially in dealing with, like I said, flex and rigid flex. So let us know what it is you're trying to achieve, and we'll do everything we can to help you out. So, and then going on to the next one is just using pre-approved STACKUPs, right? So in short, here are 2 things that you can follow to help save time and money on your order. Take advantage of our STACKUP calculator and our STACKUP engineers, so Teresa and Omar, they do a great job. These are 2 free tools that these are 2 free tools that are going to help you figure out some of your design rules and give a STACKUP built by us, something we've already looked at, something we've already acknowledged as functional and manufacturable. But this basically, it's to help things run smoother, and you can check out the link below here on the slide here to check that out. So the second thing is a great way to save money on your order. Time and money is what I should say. Time is, again, very important. So when you're not using a common STACKUP, just kind of like Elijah touched on earlier, if it's not common, our engineers are definitely going to take a look. We're going to review, double check, have another engineer look at it. It goes into several different variables, but anything outside of the box is going to definitely take some review. Do you have anything to touch on that, Elijah?
Yeah, I mean, just kind of reviewing what you said. Definitely take advantage of our STACKUP calculator and, more importantly, our STACKUP engineers. 2 free tools that are going to help you figure out some of your design rules and STACKUPs that are built by us, and we're designing this STACKUP to help you out, but you have to approve it. And that's what we're here to do, is help you guys keep your order running smoothly. And the second thing to help save some time and money would be using common STACKUP details whenever you can. each board shop kind of has their standard specs or their vanilla boards that they build every single day. And for example, here at Royal, something like a 31 mil thickness, 62 mil thickness, 93 mil thickness, 1 ounce or half ounce, Enig or Hassel finish, green solder mask, white silk screen. Those are our cookie cutter boards that we do every day here. And whenever we can, we try to merge those jobs onto multiple panels, and that helps save everybody time. When you can follow those cookie cutter specs, it definitely saves you money.
And that's the Osh Park model, right? Everybody uses the same stack up. Everybody gets their projects put on one big panel, and then everybody saves, right?
Exactly.
But if I am buying my own board, green solder mask costs the same as purple solder mask, right? We don't care.
Absolutely. Not many shops do that, but we offer any color you can think of.
All right.
At the same price.
All right. I just have to do it again, guys. I'm sorry, but I have to. Let's finish with finishes. I know you guys are welcome. Thank you. I'll be here all week. Don't forget to tip your waitresses.
Thanks. So there are so many different options when it comes to finishes. Options are almost limited, right? Or limitless, right? So what we want to do is help to make sure that you pick the right one for your design. So for those who may not know, a finish is used to protect the copper, right? So copper oxidizes quickly when it's exposed to air. Oxidized copper will not form that intermetallic bond and create issues in your board. So we use that finish to combat that oxidation. So what we'll do is we'll go over some of the most common finishes that we currently use or something we see often here in our shops. The first one you see on the slide here will be hot air solder level. It's also known as Hassel. This comes in a bunch of different flavors. Well, I should say 2 flavors, lead-free and leaded. But Hassel's achieved by covering the exposed copper surface with a molten metallic solder, obviously. It's the most economical option cost-wise, but it's also very inconsistent. So the topography varies in surface heights, which makes it difficult for paste stencils during assembly. And it also makes a paste printer, which is one of the more common paste application methods used now, it makes that unavailable. Right, so it's just so uneven that it's not as consistent as we need. So this will save cost on the boards, but generally speaking, it's actually going to add cost to your assembly. So where you're saving cost, you're going to spend it somewhere else when you go with that one. I recommend it for something like if you're hand soldering a prototype, 1 or 2 boards, it's definitely not an issue. The second one that we have here is organic solderability preservative, or OSP. And this is achieved by applying a thin layer of chemicals onto the PCB, shielding the copper from oxidation. It's also very cost effective, but unlike Hassel, it lays flat, right? Because it's sprayed on. So it makes the assembly paste options very easy. The only downside to it, if you think of it kind of like a clear coat or a thin clear coat on a car, it's vulnerable to scuffs, scratches, chips, and all of those can expose the copper and compromise your board's integrity. Our next one is probably one of the most common finishes that we see here. We can go to the next slide.
Yeah, I clicked it. I'm waiting for it to load. Sorry.
Don't worry.
It's the hotel internet. Go ahead.
Oh, man. So one of the most common ones we see here in our factories is electroless nickel and immersion gold, or Enig. Enig is when nickel is deposited over the copper in a catalytic reaction. Once nickel is adhered to the copper, it's plated with gold to assist in conductivity. This does carry a minor cost adder, but it's proven to be one of our most effective finishes offered. And then finally, our last consideration will be electroless nickel, electroless palladium, immersion gold, also known as AnyPig. Okay, similar to the Enig process, but with palladium is being introduced after the nickel and before the gold. So AnyPig offers the same durability as Enig, but with an added feature of it being wire bondable. Okay, so for you designers or engineers who need that wire bondability, AnyPig is a great selection. So again, choosing the right finishes for your design and application is critical. There are more finishes offered, obviously, in different flavors, but these are the most common that we see here in our shop.
All right. With that, do you guys have any final thoughts on turn time and cost considerations? Any gotchas or any things that you think people should look out for?
Basically, some of the best ways to save on cost and turn time is to consider the necessities. What is it you need? And do you have options available to you? Knowing those options and seeing if there are considerations is going to play big. Again, using our engineers to help you in your design is only going to save you money. It's going to make it easier for them to build. That's less work they have to do during tooling. Maximizes their exposure. So we're going to know exactly what you want. It's definitely going to play a big part. Just like I said in the beginning, bringing up any of your concerns during time of quote, let your sales rep know, let our team know, hey, these are my concerns. I have a blind here. Do I really need it? Is there an alternate method? I need wire bondable, but I also, don't need X, Y, and Z. So all of the concerns that you have, all the questions you have, bring those up. Let us give you some type of recommendation or some type of direction. Or if there's something you absolutely need and can't do without, let us know those as well, and we can make adjustments on our side. The impedance calculators, online DFMs, suggested stackups, everything we covered here to help you save on your design. Communication is key. So just like I said, reaching out to us, talking to us is the best way to make sure you get the best bang for your buck.
All right. With that, the questions have been coming in fast and furious. I know the Gracia brothers were hoping about setting a record today for attendees, and I'll tell you, we've set one for questions open and answered. We're at like 50 right now. It's crazy. So let's ask a few, and then we're going to let you two get back to work, and I'll answer what questions I can. Everybody else, we're going to have to follow up with you after the fact, but I'm really happy that you guys have been participating. That's great. So question from Enrico, should we panel or should you panel? Who should do the panelization?
We would prefer to do it. We definitely have some software that kicks butt at that. And if you can just give us some specs, if you have any specifications, like how your dimensions that you want, how thick you want your rails to be. If you have anything special, like maybe gold tips or a plated edge, we would prefer to decide where that goes, because sometimes customers put them towards the center and that starts creating problems, and we're going to have to move them out to the edges anyways, just to actually make that possible. So let us do it.
All right, file formats that you prefer.
That's going to be Gerber 274X. We also take,
do you take
ODB++.
All right.
I mean, anything you guys send, we can convert it. It might take a little bit of time, but those are what we prefer.
All right. So it is now just about done. And if you guys have time to stay, stay. But if you don't, feel free to get back to work. But I'd like everybody to know that this presentation will be made available on Royal's YouTube channel. And if you go to royalcircuits.com/blog, you'll also find the presentation. Might take a day. It might be a little bit less, but I just don't think we can get to all of these questions, but we'll try to. Okay. So aspect ratios. Elijah, if you have time for a few questions, do you?
Yeah, definitely.
Okay. What's the industry standard aspect ratio? I believe this is related to vias. How much more expensive is it if we exceed it? So now we're getting into yield questions as well.
Okay, yeah. Our aspect ratio is going to be a 10:1. So for a 100 mil board, the smallest we're going to be able to go is 10 mils. After that, we start breaking drill bits and getting into problems. We can break that, but it becomes more expensive because we're going to have to basically build the center of your board, drill that, add the outer layers, and then drill it from each side to create that through hole with a smaller size. So it's possible, just a little more expensive.
All right. Do you stock any aluminum-backed materials?
I know we do. I'm not sure exactly which ones, but again, like I said, we have a little bit of everything. If you could see our stock room, it's pretty big. It's amazing what we carry.
And to add to that, Greg, usually the aluminums are chosen for thermal reasons. there are some dielectric materials now. In Selectro, you can talk to Chris Hunrath or, you know, talk to the Rogers folks. But I mean, they're well over 4 or 5 watts per meter Kelvin at this point, you know. So you don't necessarily, depending on what you're doing, you don't necessarily need aluminum like you did in the old days. So hit us up with a specific question and we can answer more specifically. Back when we were talking about flexes, the question, it's not quite complete. It just says floating finger flex builds 2 are possible. So I believe they're just asking, can we make floating finger flex designs?
Yes. Yes, that's something that we've done here numerous times here at the shop. So yeah, floating fingers definitely are an option.
Okay. Question is, all other variables aside, how does 1 ounce, 2 ounce, 4 ounce copper selection affect cost?
So the thicker the copper, obviously, the higher the cost. So usually our standard is about 3 ounce. And depending on your design, sometimes we can let that slide 3 ounce plated up to 4. There'll be a minor cost adder. But once you start getting into heavier copper, 4 ounce and above, your cost definitely starts to increase. There's several different processes, different calibrations, different things that we need to change and make up for during all of our different processes while manufacturing the board. So the thicker the copper, the heavier your copper weight, yes, it's definitely going to increase your cost as you as that weight rises.
All right, thank you so much. Preferred mouse bite via size. Mouse bites or rat bites for board separation.
Our standard is 20 mil.
Okay, do you have a preference over, say, V-groove versus mouse bites?
We don't mind. I mean, we deal with both of them every single day. I wouldn't say there's a preference at all. Mouse bites are going to be a little faster if you're looking for that. They're going to be done at the same time as drill or the mechanical drill. And then V-score does add a step. It doesn't take too much longer, but I mean, we're fine with both.
Okay.
And that goes great for rigid. Sorry, I just piggyback off you really quick, Elijah. That goes great for rigid with flex and rigid flex. Flex especially. Flex isn't able to be V-scored, so we actually prefer mouse bites.
Are all of your manufacturing lines are all of your manufactured PCBs halogen free?
No, they are not. That's a special material. We even use a special solder mask on that. Everything's done a little bit differently.
Okay. Do you expect formal stack up and drill tables with the Gerbers?
Yes, whenever you can, absolutely. That's a huge time saver for everybody. It really tells us, it gives us a great direction of what we need to be doing. And yeah, it again, saves time and money.
Riki, referring to finishes, what's the cost differential between the 4 finishes we discussed?
So Hassel is going to be your most economical. There's usually a minimal charge to it, not to put an actual price because it's dependent on your design, but usually around like $50 or something like that. Most of the times we can waive it. Even going all the way up to ENIG. ENIG is not as expensive as it used to be when I first started. So it's not a major cost difference, maybe about $100. So it's nothing too crazy. And that'll be on top of, you know, your overall build and depending on panel counts and so on and so forth. Once you get into like the hard gold, the AnyPig, you start, you know, playing around with, and I forget how to say it, but it's AnyPig without the nickel, things like that. Anything custom, that's going to significantly drive your costs. So it can go it can increase anywhere from the more custom finishes can go at 100 to 200% based off your ENIG pricing.
All right, thank you so much for that. When working with white solder mask, do you experience any negative feedback after assembly with discoloration? Are we seeing discoloration on our white solder mask?
So that was a problem we actually had probably about 3 years ago, if I remember. It was turning pink every single time, and We actually had our vendors come in, help us figure out what it is that we were doing wrong. And it was actually part of our plating process that was starting to mess that up, or our finish process, sorry. And we got that corrected, and now there's no problems. You get white when you ask for it, no problems at all.
And we've got a solder mask printer now too. Did we have that 3 years ago?
We
Or
did
were,
not.
were we still screening?
We were still screening. We still screen also, but yeah, we just last year we started using the printer, and that thing is amazing.
Okay, signal integrity questions I'm going to hold. We can do those through email though for you if you want to reach out to us. I've also got our engineers' emails on the screen. If the questions aren't right for them, please feel free to send them anyway, and they will get it to the appropriate person to ask. So Stephen, asking about signal integrity with the vias, I'd be happy to help you with that. They can bounce the question to me. The tolerances for these for a specified impedance, I'd prefer that we sent that straight to our STACKUP engineers, just so we can really answer everything very authoritatively depending on your specific circumstances. VAMC, antenna design, that's getting into signal integrity again. I'd be happy to help you out with that, or we can send you over to one of our STACKUP engineers again. Reliability questions, we can see if we can answer you. So Tom, this is your question. About reliability and LAN cycles, I can try to help you out with that. Lower impedance tolerances, again, for Hamid, I'd like to direct that to our STACKUP engineers. And VAMC, do we have tools to help you with thermal performance of PCBs? We do have some articles on it. I'm not aware of any, if you're asking for like thermal simulation tools, I don't know that we have that available. Are you guys aware of that by any chance?
No.
I'm not.
Yeah, I'm not either. But we do know people that are. We can connect you with BQR, and they've got some plugins for some standard things. So hit us with your questions, and if we can't answer them, we'll get them to you. Please remember that, you know, all of this engineering service that we do for you is free. It's there's no charge, there's nothing. Even if you don't use us for your boards and you'd like to use us for knowledge, please feel free to do so. With that, you do have the contact information of Riki and Elijah on the screen today. I hope you've enjoyed this presentation. This has been, I tell you guys, this has been the most questions I've ever seen on a webinar that we've hosted. So congratulations on that, Gracia brothers. I'm proud of you. You did really well. And anybody else, please feel free to reach out to us. If you have requests for future webinars, that's how we get our ideas. So please feel free to send those to us as well. And with that, I'm going to go ahead and end this presentation, and we'll see you all next time. Have a great day. Bye.
Thank you, guys.